Okay, so we've done the law of cosines. It might be helpful to write it down. Anytime that we have c squared, we know that c squared is equal to a squared plus b squared minus 2ab cosine capital C. Given any triangle, this is a way to relate three sides and an angle. So here's the first problem. Two ships leave a harbor at the same time, traveling on courses that have an angle of 140 degrees. So I'm going to sort of draw a vertex and draw one ship going one way, another ship going another way, and we're going to say that there's 140 degrees in between those two directions. The first ship travels at 26 miles per hour, and the second one travels at 34 miles per hour. How far apart are the two ships after 3 hours? Well, here's the problem. I want to know what this is. I want to know the distance between these two ships, and we can see that we make a little triangle here. I want to know what this is. We're going to say C equals question mark, and I can't use this and I cannot use this as my side lengths because those are different units. Those are in miles per hour. But if you remember that distance is equal to rate times time, as long as everything's in the same units, then let's just draw a second triangle. Label that C, label that 140 degrees. I know that this will be 26 times 3, because for 3 hours this thing was traveling. 3 hours times 26 miles per hour should give me the number of miles. And then I know that this over here is 34 times 3. They both left at the same time, and we're taking the snapshot of what things look like at the same time. So, c squared minus 2ab sine C, or cosine C. I'm going to do C is equal to the square root of 34 times 3 is 102. 102 squared plus 26 times 3 is 78. 78 squared minus 2 times 102 times 78 times the cosine of 140. Take it, plug it into your calculator. So square root of 102 squared plus 78 squared minus 2 times 78 times 102 times the cosine of 140. Close before I hit enter. Let's check that we're in degrees mode, and we are. And we press enter, and I get 169.3 miles. I'm going to choose to round to the nearest tenth, so C is 169.3 miles. Okay, moving on to the next problem. Two airplanes leave an airport at the same time. One flies north 55 degrees west at 340 miles per hour. Here's the airport. Here's the plane flying north, but then we're going to say not north, it's actually 55 degrees west. So we're going to build kind of an arc like that, and at 340 miles per hour. So I'm going to write 340 here. We'll leave that kind of sitting there. The other one's south, 30 degrees west, like this, 390 miles per hour. Okay, well now I'm going to take this and sort of transcribe a second triangle. Same thing. Now I have the distance here between the two planes represented by dotted line. I'll call that C, and I'll call this C. This is 340 miles per hour, and it's 2 hours, so that would actually be 680 miles. And then 390 times 2 is 780 miles. There's actually an interesting YouTube video that I'm sure some of you have seen where this guy's trying to explain to this girl why something along the lines of, okay, so I'm going 340 miles per hour, then in 2 hours, how many miles will I have gone, and how it's not that complicated of a calculation. 340 miles per hour times 2 hours, it gives you the number of miles you travel. But the key thing here is knowing what this angle here is. I need to be able to take that and say, what is this angle? Well, if I look at this,
that's 180. That line's to be 180. So I actually have 180 minus the 55 minus the 30 to get that interior angle. And I get 95 for that. So this little angle here is actually 95 degrees. Then I can use my law of cosines again. C equals square root of 680 squared plus 780 squared minus 2 times 680 times 780 times the cosine of 95 degrees. Plug this in the calculator, so square root of 680 squared plus 780 squared minus 2 times 680 times 780 times the cosine of 95. Close. Enter. And I get 1,078.5 miles. Take that, transcribe it. C is equal to 1,078.5 miles. Now I want to go back up to the first one for just a second. In math, we do ask in word problems for you to write your answer in a complete sentence because we want to make sure that you've actually answered the question. So, for the first one, the ships are 169.3 miles apart. And the second one, the planes are 1,078.5 miles apart. Okay, moving right along. We have a triangular parcel of land. The word parcel means piece, so don't make that too complicated. Has side lengths of 680, 320, and 802 feet. What is the area of the parcel of land? If the land is valued at, well, let's answer the area question first. We know that the area, and if I kind of label this with A, B, C, we know a few formulas for area. I know that area is equal to 1/2 base times height, but we also said that that's 1/2 AB sine C, or any of the other combinations, BC sine A, AC sine B. It doesn't really matter which one we do, I just need to find one possible angle. So what I have to do is I have to use the law of cosines to actually figure out an angle. I'm going to go for angle C because that's the one we've been doing. So we're going to say that this is equal to little c, this is equal to little a, and this is equal to little b. And I'm going to use c squared is equal to a squared plus b squared minus 2ab sine c, or cosine c, my bad. Interesting to note there, that is actually the most common mistake made in these problems, is replacing cosine with sine, because our area formula, the area of a triangle, uses sine, but this uses cosine, so just be careful with that. Alright, I'm going to solve this for capital C. C is equal to little c squared minus a squared minus b squared divided by negative 2ab. Forgot to write the arc cosine, so let's shift this to the right. Arc cosine. Do some substitution. That's arc cosine of 680 squared minus 320 squared minus 802 squared over negative 2 times 320 times AB. So that's 802. Close. Okay, let's punch this all in the calculator. Arc cosine alpha y equals, build a fraction. Put back, so that's 680 squared minus 320 squared minus 802 squared over negative 2 times 320 times 802. Over to the right, close, and then crap. What did I do wrong? Let me figure this out for a second. No. Oh, I know what I did. Hopefully you saw it. 2 times. That should be a times. Boom, 56.5 degrees. So I can get the crap out of there, but that's more fun to keep it in. Okay, so we have 56.5 degrees. Okay, that tells us one angle, and then I'm going to take this, since this was angle C, I should probably say the measurement of angle C, just to be more geometrically correct. Take that, plug it in back here. So area of the triangle is equal to 1/2 little a, little b, and we want the sine of 56.5 degrees. So I'm going to use a calculator to kind of recall this sine value since I have it stored as the previous answer. 1/2 0.5 times 320 times 802 times the sine of the second answer. And it's going to pull the answer right from above. And I have 1,000 or 107,019.8. And that's feet squared. So that is the first part of this problem. Then it says that the land is valued at $2,100 per acre. What is the value of the parcel of land? So I'm going to kind of put this. Ooh, I can move over here to the right. Hopefully you have space. Okay, so we're going to start at the. We're going to do this dimensional analysis style. I'm going to say 107, 019.8 feet squared. I'm going to set this up in fractions, and we're going to use conversion factors. The first one is to convert it to acres. So that's how many feet squared we want. This thing says 1 acre is 43560 feet, or square feet, so there's 43560 feet squared for every 1 acre. And then finally, I know 1 acre has a cost of $2,100. So acres crosses out, feet squared cross out, I'm left with a dollar amount. I'm going to go back to my calculator and say that this is going to be times. Notice how it took the answer from the previous one and said times. We want 2,100, but then divided by the 43560. And my cost is 5159.3. We'll be evil and round up and say 0.4. Actually, since it's dollars, we'll probably say 0.36. There. That is a dollar amount. Okay, we're going to move up here for a complete sentence answer. The area is 107,019.8 feet squared, valued at $5,159.36. All right. Okay, there's our final answer. Whew, okay, let's move down to number 4. We'll switch to pink. A boat race along a triangular course marked by buoys A, B, and C. The race starts with the boats headed due west for 3,700 meters. So bearing 180 degrees means the direction they're going. So here's the start. It goes due west for 3,700 meters. The other two sides of the course lie to the north of the first side. So this moves down. The other two sides lie to the north of the first side, so we're going to turn this way. We have a length of 1700, and then we have a length of 3,000 meters. And it wants to know the bearing of the last two legs of the race relative to the unit circle. So notice how this first one was kind of like an arrow there. I'm going to draw this with an arrow that way and an arrow that way. So if you picture yourself as a boat, and I want you to get this visual down, You're starting at the bottom right. You're going this way. Okay, not like that, but you get the idea. This way, then this way, and then this way. And you finish right back where you started. Well, to do this, we need to go back and figure out some angles, which means we have to label some of this stuff. So, given that this is, we'll call this A, B, and C, which means that this is little a, this is little b, and this is little c. And we want to figure out some of these angles. Well, we can use the law of cosines, kind of like we did before. I want to figure out what angle A is first, so we're going to say a squared is equal to b squared plus c squared minus 2bc cosine A. I'm going to take that and solve that for A. A is equal to the arc cosine of a squared minus b squared minus c squared over negative 2bc. And here's the interesting thing. And we talked about this in class a little bit. I can take this result and I can copy it for the others. So what I mean by that is we can also say b is equal to the arc cosine of, that would be b squared minus a squared minus c squared over negative 2ac. I can also say angle C is equal to the arc cosine of c squared minus a squared minus b squared over negative 2ab. Forgive me if that sounds redundant, but that is important in the way that we can enter these in our calculators, because what I'm going to try to do is do something a little clever. You're looking to see how I've labeled all of these. Well, we're going to plug those in our calculators using the store function. Now, on your work, you wouldn't have to write out all this stuff here. I just did that for kicks, and because this is kind of class. So, okay, let's snap this over to the right here, and let's go 1700, store alpha A, 3000, store alpha B, and 3700, store alpha C. Now, if you guys were really genius, you would store these in your calculator, but it's okay. We're going to build the fraction up again, so alpha y equals, this is going to be alpha A squared minus alpha B squared minus alpha C squared over negative 2 alpha B alpha C. There's one angle. That is angle A. Let's keep going while I've got the momentum. I'm going to recall this, and I'm going to go back and edit, and I'm going to replace, actually I'm just going to swap the B and the A so I can find angle B. There we go. Alpha B, alpha A, and then down here that should be AC. Okay, that matches the one for B. And here's the beautiful thing. Do I really need to do C? I don't think so. I can do 180 minus the other two. So really what I get is angle A is equal to 26.9 degrees. Angle B is 52.9. And angle C is 180 minus those two. So 180 minus the previous one minus, I'm going to go up to grab the 26, and I get 100.2. A nice check to do is to make sure that the last digits of each of these will add up to a 0. 9 plus 9 is 18, 18 plus 2 is 20, so that kind of works, and then everything else is, yeah, it looks fine. Okay, so now that we have that, I then have to sort of interpret this result. So I'm going to go back to this, this grid here and say, yeah, I've got this triangle here where this angle A is 26.9, this angle B is 2.9, and this angle C is 100.2. Well, really, I didn't need to figure out all of these angles. What I really want to know is we start by going Remember, this thing starts going left, 180 degrees, and then it's going to turn and go this way. So if I go to a unit circle, I want to figure out what this angle B really is. Well, that is 52 degrees. I mean, if you look at it, we're going, we start bearing 180 degrees, then we turn and bearing 52.9 degrees. That's okay. That's actually going to be the same thing. Again, if you want to see it relative to the unit circle, just kind of draw a unit circle at that corner where that angle is. Just draw the angle out the way we're going to be going and be like, oh, yes, that's 52.9 degrees. So you can say the second turn, actually it's the first turn because we've already started, so the first turn is bearing 52.9 degrees. Okay, now let's erase that circle. Let's go and look at the other one. So then we go this way, and I'm going to put kind of moving, and then I'm going to turn. Well, that turn, relative to the unit circle, I want to know what is this angle relative to the unit circle, meaning all the way around there. Well, this can be a little tricky, but what I want to kind of do is figure out, see that this thing right here, that's 180. Then this right here, that should be the same as, okay, this is going to kind of rely on geometry, but I think basically without geometry you can see this. If I darken this, and I darken this, not so dark that I can't read the 52. You'll see why here. If I darken this here, what I have is two parallel lines, and then I have this angle right here. These are opposite interior angles of parallel lines. Yep, I do remember geometry, even though I haven't taught it and taken it in a long time. There's 52.9. That's not true. I taught it for a little bit. 52.9 degrees here and here. Those are congruent, opposite interior angles of parallel lines. If you look at them, they should be the same. So what I want to do is say, I know that's 52.9. I know this is 100.2. I know this is 180. Oh yes, we're going to add all of these up to get that final bearing. Meaning relative to the unit circle, relative to basically going to the right, this whole thing here is 180 degrees. This little bit here is 52.9 degrees. And then this bit, this final bit there is 100.2 degrees. So the final turn, there really are only two turns here, is bearing. Go back to the calculator. I've got 52.9. Actually, I can do this without a calculator. 180 plus 52.9 plus 100.2. 3. This would be 3. And it's bearing 331 or 333.1 degrees. So that was a little tough. That was a little tricky. Certainly not tricky getting the angles inside of the triangle itself, but very tricky in getting what the actual angles relative to the unit circle are. So look back at the question. Find the bearing for the last two legs, angles from the unit circle. So we won't be doing that a lot, but we do have to take, to answer that question, the angles from an actual unit circle perspective. Meaning if I was sitting at the center of the unit circle, what is the direction that I'd be going? Oh, that's it.